All right, well, why don't we go ahead and get started? I suspect others will filter in. Let's see. Fine. Yeah, maybe we should start with updates on what people worked on yesterday.
Okay, I can start. So I fixed into int or fixed and improved into int. So now I provided a data type. So it tell you like we want an array of integers, like an integer, something like that. So now at least you can do more than binary or like just be clear before code already do that, but I think from the perspective of Francois is more that he expected you to write some code every time you want to add a new reference. Given that, then I repeated the demo, but I think you should look at the README and try to follow the README.
Okay.
And if you get confused, you should tell me how to do the README, or because I try to do my best. But
So just so I understand correctly, so now in both the input and the output is the format on the training data, the format is the same?
no. So you when you run the experiment, you say that the operation is a data. So it's basically says like I'm only going to read data from 1000 within, yeah. My test data and my train data is going to be all from files, and you need to give it the format. When I mean you give it the format, you say like what's the input. It can be at the moment we support 3 data types, integers. I tell you how to encode them, arrays of integers, and then or a range of integers. So
okay, okay.
So when I say a range, could be like you can say like I want. We just try to define the alphabet. So basically, you can say like I want all numbers from -5 to 5, or all numbers from 0 to 10.
And we can have an array of those.
Not yet, but I know you want. But
okay, so we should just use an array of integers that happen all to be between 1 and 8.
Yeah, you can try that and see how it goes.
And then, but then for the output that we're asking, right? So we're going to train it on a pair of sequences. Right, I want int to int to learn how to, on a given input sequence of integers, output a sequence of integers that is similar to what it would output if it was following the training data. And so what we were struggling a little bit with yesterday afternoon was how to feed in the output data, the output part of the training data, the 2 sequences. Am I making sense?
So the data structure for the input and output are both the same. They don't even be the same, but the possibilities are the same.
Great.
These 3 types.
Perfect.
There's also potentially a way to do arrays, or like sorry, matrices.
Yeah.
If you want to think about your vectors as a matrix.
Okay. And in both cases we need to prefix it with something that tells it the length of the sequence that's coming. Okay.
I do not know how to do matrices. I do not know what Francois did for matrices, but one can open it and see.
Great. I'm looking forward to trying it out. We have data. Okay, would anyone else like to report on projects that happened yesterday? I'm very intrigued to hear how things went with both predicting L functions and rational points.
So we were kind of like working also with end-to-end to learn Euler factors. And everyone was kind of trying their own experiments, so people might have different updates for that. I think I was trying to learn A2 mod 2 based on like AP mod 2 for like the first, I don't know, 100 or so times, or maybe it turns up to 100, just trying out something simple. And at some point it got stuck in guessing all zeros.
That's a good guess.
It's given an accuracy of like 53.63%. That's great. But yeah, it's not clear why it just got stuck.
But I wonder if you could address that by tweaking the training data. I mean, if you redistribute the training data so that A4 is uniformly distributed across the training set, maybe it would that would sort of force it possibly to do better than just guessing the most common value.
Yeah, I haven't tried too many things, but I mean. Yeah, I haven't really checked how the other APs were distributed.
Yeah, I'm not so much worrying about the AP, but I think if you're asking it to do a classification problem, you want to avoid a situation where just guessing the most common class is a good strategy. You want to make that a bad strategy.
Mhm.
So that's my intuition. Anybody else who worked on
I
the L
did a
function?
similar thing.
Yeah.
I made the machine predict A97, the parity of A97. And then the input was from A2 to A89, from A2 to A89. And then I made it predict the parity of A97.
And we were giving it the input just mod 2, or were you giving it the full AP?
The full AP. And then like the parity was I chose samples like a 50-50. And then but the problem is I'm not that good yet with the in. The first few epochs showed 65%. So it was a kind of surprise to me. So it's not guessing 65%, but I have to figure out more details.
Yeah, I think it'd be interesting to run like the exact same test with just giving it the A2 to A89 mod 2.
Yeah.
In theory, maybe it's just learning mod 2 gamma representations.
Well, that's what I was gonna say, that an interesting question. Sorry, I didn't mean.
No, please, go ahead.
Well, so I mean, a natural question is, whatever your guys' things are learning, if you then pass it data which looks like a piece of modular curve, but I've just replaced everything with it plus some random even number. I mean, you
Yeah.
could test whether it's, which I think it would be correct for it to sort of only pay attention to
Yeah.
the APs mod 2, because you know, if you have the first 100 APs and you know them all mod 2 in any reasonable conductor, you know the mod 2 representation is determined. So what A97 is, mod 2 is determined. So I don't actually know what to expect, but I mean, I don't even know if I feel this is like a moral question. I want to say it should only pay attention to the input mod 2, but maybe, I don't, maybe that's a wrong intuition, but as a mathematician, I feel like that's what it should do, but I'm curious as to what it actually does do. It's just always one of those questions, is it automatically learning the symmetries of the problem, or is it not?
Yeah, I mean, I guess if you believe in lifting theorems, maybe you think there is information in the Archimedean sizes of the.
Yeah, no, it's not a priori impossible that there could be information, but I feel like surely almost all of the information in this range is
Yeah,
contained
I
in
would,
what the
I would
APs
agree
are
with,
mod
I would
2.
agree with that intuition. Yeah. Okay, anyone else on who did L functions want to say anything?
I think I was mostly in the room. I was most trying to think. I think what people spent some time was trying to, as I speak, with about right.
Someone him.
I think you can tell, like we're trying to design experiments that we want to run. And I think Jordan got excited about some of them, even though they have not been run at all. So,
I'm
very excited about the movies. We have a lot.
I'm glad you said even though and not therefore that.
therefore.
Like I was excited, therefore he decided not to do that.
No, I think, I don't know if, basically the idea is that trying to just take away the mathematician had away and just like, what experiments can we run?
Yeah.
With these transformers, there's a black box, these whatever, and to see what it produces, if something surprising or not. Well, like other factors can be very precise, but like something as basic as mu n might be more interesting. And if you can do something better than before, or learning less than a symbol, I don't remember what was on the board anymore.
Yeah, we came up with like 20 ideas. We're just like, hey, let's just throw lots of things on the wall. We're gonna see what sticks.
And you're using int for this?
Int.
And what's the input then? Is it literally just an integer? Tell me mu.
So we haven't set that one up. One that we thought would be interesting is maybe if we do n mod p for lots of small
Yeah,
bits,
I like that.
because that one's an interesting one.
Yeah, that seems more in line with sort of the L function. I mean, I like the L function, the mod 2 or mod L representation, because you're giving it a lot of information, that at least in principle determines it.
Yeah.
Although with the mu n, I guess it depends on how big it is.
Right.
Yeah, I like that too, because I feel like somehow it seems to so far have clearly failed to like input an integer as anything like a real number or something. It's just like it can't see its arithmetic structure, but giving it mod p for a lot of p is somehow giving it some of the arithmetic. It doesn't seem to me obviously giving the game away, right? I mean, we'd have to think about it, but it's like
Yeah, I mean, there
How
should
much
be, it
room
should
do you
have
have to
some
give it?
prime divisors that are bigger than the ones you're giving it, but if it knows the Chinese remainder theorem and assumes, yeah, it can figure it out. Unlikely.
You can also give it, not just n mod p, but the genre symbol of n mod p. Because I think in like the best algorithms to determine hobbies of n, that's what input they use.
Yeah.
Yeah, I'm not against giving it like even more information. I don't know how strong I should expect it to be. Like maybe it's very bad. Like, can it reproduce the Chinese remainder theorem? Like if I just wanted to recover n from n mod p, can it? I have no idea actually. Maybe,
Maybe that's a better question.
you know, I'll do that too, because hopefully it can. But yeah, that's a good idea too.
Yeah, I think talking from Francois, they always believe that this game of like, you're trying to teach someone Chinese, first you teach them, let's say they speak Portuguese, and first you teach them English and then from English to Chinese, they're like, no, just go all the way. But as a mathematician, I think maybe it's worthwhile to, can they speak CRT first?
Well, I like the idea of running lots of experiments, I think, yeah. Seems like a good strategy.
I was just looking at the source code of Intuit to see how, in the source code, how Francois constructing embedding and encoding, to figure out exactly what's going on.
And did you figure anything out?
Sort of. So in Francois' experiments is that he kind of gave he generates numbers as in integers, and then he'll give x and y the labels and the inputs the same encoding, and it will go through like a neural network that gives you like the random embeddings, and then through the training that's these integers are not integers anymore, they will have the same meanings. So in our case, we kind of, at least in our AP experiments, we gave it encoding in the sense that it's pretty much just plus or minus. It changed the string to plus or minus that number. So it becomes plus, it's as a string form, plus or minus 1 or plus or minus 2. Just trying to figure out if that how much does that matter, and how much does it matter in terms of going into a transformer.
All right, I guess the other big project was that had a lot of people interested in it was rational points on genus 2 curves. Does anyone want to?
Yeah, I can say a few things about that. So people were spread across different places. Like some people had to go to be, Jen and Padma had to go back to BU, and so like I was speaking with different people at different times. I had a chat with Mike Douglas, and he and then subsequently with Kit, Melanie, and Noam. And from that, there's like a few different ways to proceed. So what, as Mike was saying yesterday, is like there's a question even of how do you represent a genus 2 curve. There is an obvious way of saying it's y squared equals f of x, where you need 7 integers to define f. But maybe that's not the best approach. He was kind of suggesting. So in addition, there were these messages, and so you had sent Noam some emails about like how he and Stahl had found this record-breaking curve, and they were using these K3 surfaces of discriminant minus 163 that already had a lot of like all of whose, like, when you take lines through it, like those genus 2 curves already have a lot of rational points. So from the subsequent discussion with Kit, Melanie, and Noam, it seems we're converging on taking one of these families that Noam has, let's say S. So you have y squared equals S of TUB, and that's an explicit polynomial in 3 variables, degree 6. And what Noam is doing is taking AT plus BU plus CV equals 0. And so you have A, B, and C. For different values of A, B, and C, that's going to give you a genus 2 curve that's going to have a lot of rational points. And the game is, can you find A, B, and C such that the specialization has even more, possibly to break the record? So yeah, there was this idea of potentially of using fun search, or like Kit's fork of fun search, which is apparently like sort of good to go. So that's something I want to work on today. But basically, we fix an A, and then can you use a? So we have to design like a priority function or a scoring function to select the B and then subsequently the C. In order to maximize the number of points. And what's going to go into that priority function is going to be the AP and the BP values. So let's say essentially the numerator of the zeta function. So that's like a proxy for the number of points of the curve mod P and the Jacobian. And so that's kind of encapsulating the heuristic that if it has lots of points mod P for lots of primes, then it should have a lot of rational points. So
But what's doing input? So I'm confused about this. What's the first search prioritizing on what? It's telling you how to pick A and B.
so we're gonna fix an A, let's say A equals 1, and then we're gonna want to find the B and the C.
Okay.
And it's using so it's unfortunate that I'm using the same letters. It's gonna use the AP and the BP
Of what?
of the,
The curve you get when you slice, the curve you get when you slice, right?
yes.
But that's not a curve
a
difference,
family,
right? It's a
right?
family.
It's a
That's what I'm
family of
confused about.
curves.
No, I think there's a surface and then Barindra's picking a hyperplane and cutting that surface to make a curve, right?
No, not when if you figure an hyperplane when you fix A, B, and C. But
Ah,
if you have
Yeah,
A fixed and B
yeah.
and C are not fixed, you still have a.
Yes.
That's what I'm
I see.
asking. So if you have a family of curves, are you going to look at the family of Jacobians? There are two things you could do. Yeah, you could look at the family of Jacobians and try and
Yeah,
see if you can
I wish
use
Melanie,
the generic.
I wish Melanie and Renee were here, but they had some way of saying that we're gonna look at the AP and the BP values of the curve itself. But yeah, well, I agree, you need the B and the C for that.
Well, I thought that's the point. You produce candidate B's and C's and then compute AP and
Yes,
BP
we could
for
do that,
for that curve.
So maybe the
I-
zeta function is being used as a way to score, is that the idea? You're looking
Yes.
for good B's and C's that give you a large number of points?
Yes,
Yeah.
that's the idea.
Do I had a question yesterday, but maybe this is like, longer work. So we know a few curves in these families which have lots of points. Maybe we could try and interpolate through those curves and try and find some family. And hope maybe that lots of members in that family have lots of points, but I maybe this won't work for like mathematical reasons.
No, I think that, I mean, I know another suggestion Noam made that was independent, I think, of this one was looking at the torsion data we have for this large data set of genus 2 curves and trying to interpolate families that try to discover a parameterized family from that data and then search it to see if you can find a specialization that does even better. than
Yeah,
the
in that
examples.
family. Yeah. So I don't know if we could do. I don't know how to score a one parameter family.
So can I ask a sort of adjacent question, which is, and there's people in the room who know this much better than me, but like, I mean, obviously we know it's a famous problem to try to improve on the bound for rational points. You're talking about using this AP and BP as a proxy, but do we even know for any decent sized P, like what the actual possible APs and BPs are for a genus 2 curve?
Sure. Yeah, I mean, we know.
Oh, because they're all abelian, it's the same as A2, I guess. Is that
Yeah,
right?
I
Because
can hook up. Yeah, I mean, and there might be for small p's, there are a few excluded values, but once p gets big, every possibility can be realized, and I can use the CRT to match whatever Euler factors you
But
want.
But just so I understand, is that's because every abelian surface is a Jacobian? Is because we have Tate Honda or something? Like we wouldn't know.
No,
the
no,
entire
no,
genus.
no. I mean, over Q, not every abelian surface
Oh.
over Q is a Jacobian, and they're like
Oh.
you can like in the.
But even so, we know all the possibilities. I didn't realize.
Yeah, I mean, I'm not sure we can prove that they're all realized infinitely often, but you could go into the abelian varieties over finite fields database. And for all the genus 2 curves, we know exactly which ones are Jacobians, and we can say which of A polynomials can be realized as a Jacobian of a genus 2 curve mod P for every P up to 211. And there are some combinations that can't happen because they imply a negative number of points on the curve.
I see.
Yeah,
Okay.
For genus 2, there's a condition like in terms of A and B.
Yeah, Everett Howe.
But the point is,
Isn't
there's
it
no
fair
juice in
to
trying
put
to
all
like
the things
find
that-
extreme values because that's already known. That's sort of what I was asking. I mean.
Yeah,
if we're
I
talking-
think for the
okay.
genus 2 case, we know how to produce extreme, like I could cook up a curve with ridiculously big coefficients that would have the maximum possible number of points mod P for your favorite set of P. And then as soon as you get outside that set, all bets are off. So I think it is one reason to be, in general, be cautious about these heuristics. On the other hand, if you assume the coefficients are small, which they're necessarily going to be because you're not going to be producing huge B's and C's, then it probably is a good heuristic that if it has a lot, it's modulo a lot of small primes, that they may be coming from global points.
It's just coming from outside, this, it sounds to me like it's more of a classic search problem. It's not like searching for a function like fun search. It's searching for something described by 3 numbers in the case of Noam's curves, or 7 numbers or 10 numbers. So that speaks to trying to understand the number of points as a function on that space, and just use one of the other methods, either the straight reinforcement learning or some kind of data science to understand structure of the number of points as a function on that space.
I think one way to make it fun search is trying to, now we have two parameters, you can just make it like, give me P1. So give me an parameter, like, tell me how to write C in terms of B and A. And then, but I don't know if that's gonna get you anything.
Yeah,
I mean,
you could do it. Well, again, if we expect that structure, if we expect that there really is a interesting function of that sort, which is relevant for the problem, then I would agree that that's worth looking for. Do we expect that?
I mean, one thing I could imagine Fun Search finding is if there is some subfamily inside this, there's something that intersects this K3 in dimension greater than 1, that where you're more likely to find points, it's conceivable to me that a genetic, algorithm, a heuristic search might find it better than a brute force search. Because you might not hit it on the nose, but if you somehow chose a hyperplane that intersected that subfamily in more, small height points, you would do better, and that might sort of steer you towards finding it. I don't know.
That's maybe closer to another idea that Mike had, which was like using int-to-int basically. So like the input would be like these 3 numbers ABC, so that gives you a genus 2 curve, and like the label would be like you can run a search for points up to like height 10 to the 7. So that's then like a sort of transformer model one can use, and that could then be looking for like hyperplanes that do have a lot of like points of small height.
Well, so the point was that you can do kind of a genetic like search without doing generating functions and using the language model.
Yeah,
You could say that
Just the more traditional genetic algorithm, is that you mean?
Yeah, we're working in this space of vectors of coefficients, and then the variation that I guess Gordon, we're on this, Francois and so forth, would be to train some model, which in this case might be a transformer, on a lot of good examples. So, curves with many rational points. We have just we start with a big list of them, and we train a model to try to reproduce a probability distribution that favors those curves that have many points. And then hopefully that will contain more candidate curves with many points. And then we sort them by the value, the number of points, and keep the top ones as a new population and keep doing that. So it's not genetic in the sense of combining programs as the Fun Search did, but it's sort of, Francois' term was population genetic. We take the best N and we use it to train to get more things like that. So that might be a good approach. So then the model, there's a generative model, which, doesn't in itself have an input. It just generates curves, which are supposed to come out of this ensemble that favors many rational points. But one could use a transformer with a random input, or one could use a transformer autoregressively to, just, generate the sequence of numbers in that vector. And then you would train it on that list of example, good curves.
So can I ask a question, which is, you said, wait, first of all, so who's, okay, this kid, somebody in the room. Okay, hi kid, okay. So there's like a working local fork of Fun Search now. Oh, that's awesome, because we definitely failed to be able to get that working at Wisconsin. So I mean, I think I'm just gonna say, as an adjacent question, I think trying to think of truly arithmetic questions that are well adapted for Fun Search is like a very interesting question I would like to spend some time today thinking about, because I sort of
that 1:30, right? We have it.
There's a specific session,
for Mistral, for the Mistral project.
At 1:30. Yeah.
Is that separate? But is that separate from your thing, Angelica? Is what's I'm sort of lost about what everything is.
Look in general.
It's before the class.
Okay.
I think this is more or less like kids has implemented the whole thing for, I think, for Fun Search.
And parallelized.
Oh, great.
Running
Okay.
at scale.
Okay, so I'm not thinking about that till 1:30. Okay.
We can talk about it.
Okay.
before that.
Yeah, you're allowed to
Go
think
before then,
about
that'd be
Okay.
sad.
But yeah, I agree.
brainstorming of the
Yeah, I was just gonna say, maybe for the, if it turns out for this genus two curve problem, an end-to-end approach is better, I'd still like somebody to
Mm.
exercise this new toy we have,
Mhm.
because I think it's awesome that we might be the first ones outside of DeepMind that could actually replicate, some of the fun search
Is it-
stuff, and we've
yeah.
got Jordan here for a few days. I think it'd be great to go to town with it, and yeah, we should all.
So, well, can I speak? We had a conversation earlier, maybe.
Well,
you should-
the
Yeah,
constraint
there is a concern.
is budget, basically, and
Yeah, yeah.
it seems roughly clear that what we can do with our budget is comparable to two of the big searches that people did.
However,
Exactly.
that's not including,
Not including any
tweaking and
calibration,
optimization and stuff like
optimization,
this.
that sort of thing. We
So-
have budget for two
Yeah.
large
so we
searches.
don't want to be too
Well,
experimental.
do you know the number of trials, Kit? How many
So I know
calls
for the
did it?
symmetric set 1510, the I-1510 problem, they
Yeah,
did, they
yeah.
generated 2 million prompts. That would cost us around $1,500.
So, yeah, probably, so given time to then, calibrate stuff and set it properly, probably one realistic big run of something is what the
But,
budget's for.
Well, once we get something working, Francois is pretty sure that they'll give us more money. The main
Okay.
point is to show something is promising.
Oh, cool. Okay,
Okay,
great. That's
that's
great.
Yeah.
That's better.
Yeah.
Don't appear, but yeah.
Yeah, I would say that, I would repeat what Mike said, independent of what Mistral
Mhm.
says. If you have something that looks promising, we will find a way
Okay.
to let you run it at
Yeah.
scale.
Yeah.
Okay, so there's lots of scope for calibration.
Yeah, yeah.
That's good.
Yeah, Mr. Qualified to Jordan, so I think, so Kit has implemented fun search, I think with a target cap set, but I think abstractly enough that can be
Oh,
modified.
yeah. I mean, it's implement, we've got it in principle working with 3 points on a line, cap set, Sam Spencer. I mean, those are the three that we've actually written the
Ah,
skeleton for, but it's basically trivial to write a skeleton.
And Angie's demo, which we got about to see in a couple minutes, is more like, if you want to do fun search, even Gemini for free, you can.
Right, this is what you showed me a little bit about. Then you showed me a form of it when I was here before, right?
Right.
Yeah, awesome, okay.
Just give you like basic structure without you don't need to have like thousands of tokens from Mistral, you can just try to run it yourself. You're not going very far, but it gives you a place to play.
And you don't have to use Gemini either, you could use a different.
Yeah, I mean, it's incredibly cheap to play with, but you just don't set your rate limit too high and you could accidentally leave it running for a day and spend 10p. Like it's like $1. Really, really cheap.
Okay, well, maybe before we jump into Angie's demo, I should give just a quick update on the modular curve optimization project. So I posted a bit about this on Zulip and Jordan, rightly responded that he thinks I'm crazy, but I just want to.
No, I was confused, I was in O'Hare, I was, okay, I was.
But no, I would actually welcome feedback on whether this is a ridiculous idea. So, yeah, so the idea is and I don't think it's so different from the Genus 2 curve point search in the sense that you're fixing a K3 surface, you're fixing sort of an ambient space in which you're going to work. And so the problem we're trying to solve is we would like to teach end-to-end or a transformer model to be better about optimizing models of modular curves. We're going to fix a modular curve. We're going to generate 1 million different models for it. They're all in the same isomorphism class. And then we're going to run a local search that optimizes sort of fairly quickly, looks with just a short, maybe a 5-step look ahead, does a gradient descent to the lowest, the best model it can find and iterating that. And so then we have a bunch of random curves with some degree of optimization improvement to them.
Mhm.
And then we pass those two pairs, the model of the curve and the sequence of steps that optimize it, which is just a sequence of integers between 1 and 8, because there's just 8 moves. There's really only 4 moves and they're inverses.
Mhm.
And then we train Intuit on it. And then the idea is you give Intuit a new model that it hasn't seen before and ask it to give us a sequence of moves that will improve this model, with the hope being that you could then iterate it as well. Because you could then say, all right, I'm going to apply the sequence of moves. And now we have a new model in the space of models of this modular curve. And then we can iterate on that. And we could also even do something similar to what Mike was suggesting. We could also even generate an entirely new population to train on and run that iteratively.
You're scoring by the size of the coefficients?
So so let me add 2 additional things. So we're scoring by, first and foremost, the degree, because we care about canality.
Right.
But then the number of non-zero terms, we want that to be smaller. and the size of the coefficients, and there's a couple of different tiebreakers that go in there. That's basically the same scoring function that the local search uses to decide which direction's down.
So so again, the input is a pair model and then a list of moves, but in the training data, those are the moves the local search chooses. Is that right?
Yeah,
So would you say you're you're training it to imitate local search?
so I think yes, I'm training it to learn. But the hope would be that it won't do it exactly, that it will learn some. So the thing that we discover with the local search is it checks a gazillion possibilities, but it very often turns out that there's a few combinations of transformations, short sequences of 4 or 5 moves that define some some Mobius transformation that works quite well generically, not applying it at different places in the sequence or applying it to many different modular curves. And the hope is it would start to learn some of those, but in a heuristic sense that wouldn't be exact, so that we could combine that with a brute force search and some randomization in the hope of doing better. But before I finish, the other thing that occurred to me last night, that was the second post that I wrote, was that maybe giving it the model of the curve is a bad idea, because the models get horrible very quickly, like 100-digit coefficients. But maybe what I should do instead, since all the models are being generated by starting from a fixed model and then just randomly applying transformations, maybe I should just give it the random walk, the list of moves. So we can encode, so then it becomes almost like a Cayley graph kind of search, where I've got an infinite regular graph of degree 8. I've got some way of measuring how good each point of the graph is. I give it a bunch of random points by random walks. I hope to get to a lot of different random points. And then I'm trying to teach it, well, here's a good sequence of steps you could apply from here. And that good sequence is generally going to be much shorter than the random walk. So the local search has no hope of finding its way back to where it started. And where it started isn't even necessarily a good point.
So are you reversing the random walk and
No,
going back to the? I'm just what I'm confused about is I feel like if you give it a sequence of moves of which the first 100 steps are random walk and the next 5 are local search, isn't it going to learn to do random walk for a long time and then local search? That's what I'm concerned about. I think I didn't express it well in my.
Well, I guess my thought is that, so suppose I didn't give it the random walk, I just gave it a random model.
Right.
Then the question would be what that's a nice, from an information theoretic point of view, they're exactly the same. Well, not exactly, because different random walks continue to the same point, but they're close.
Yes.
And it's a much more compact representation. I like giving int to having both the input and the output just be sequences in base 8. And it's not supposed to be learning random walk plus this. It's supposed to be learning, if I give you a random walk, here's a sequence of steps that make it better.
I see. So in other words, you would be. No, now I think I get it. You're saying you're going to give it a pair of sequences, the random walk part followed by the local search part.
Yeah.
And then if you give it a different.
And then here's a new random walk you've never
understand.
seen before.
Now I understand.
It's like I'm
So that makes
blindfolding
sense.
you, I'm taking you out into the wilderness, running you around at random, and then I'm saying, okay, go find water. And then I'm hoping that by doing that to you a million times, that if I take you to a new and showing you, oh, the water's 3 steps to the right and then 2 steps left, and then I give you a random one, you'll be better at doing it than chance.
And you're saying that in practice, because if you did this in a Cayley graph way, like if you sort of did a random walk for a long time and then actually knew your way back to the origin, it would probably be just reversing the last steps of the random walk. Are you saying that that's not what happens for these?
Well, the local search has no hope of finding its way back to the origin because it's way too far away.
Okay.
It's like I blindfolded you, I spun you around 3 times, and I sent you out 100 miles over the wilderness. There's probably going to be water within a few miles of you, and you're going to find that.
And by the way, did you literally mean like 5 steps of local search? Or is that 5 just to stand in?
5 is in the sort of the limit of what I could do in the original. I could probably go 1 step further, was like 7 steps. When I say 7 steps, that's just the look ahead. It's like you find the optimum point within 7 steps of where you are now, go to that, and then do that again until you are at a minimum within a radius of 7. But for generating the training data, 7 is too large. That takes too much time. So because I want to generate millions of them, so I dropped it down to 5.
But your sequence of steps in the local search is how.
Oh, it could be, it varies. It could be,
Oh,
it
great.
could be 0, it could be 100.
That's great.
It depends on where you wind up. If you're already in a valley, deep in a valley, you may not be able to improve your situation.
Because I think the thing is that if there are indeed like short sequences of moves that come up a lot and are useful, like the auto tokenizer should like take care of that. Like it should find them like when it tokenizes, and like I mean that would be something we could actually like look directly
Yeah,
at
yeah,
what
yeah.
the tokens are that BPE makes or whatever it is you choose to use.
Yeah, just looking at the distribution of short subsequences could be an interesting thing to do.
Yeah.
Are you, I mean, you said the first thing you wanted to optimize was the degree. Are you also counting points mod P? Like if you've already reached the gonality bound and you're not going to improve that, maybe you can tell it to ignore that and try and optimize the other parameters.
I hadn't thought of that. That's another. Yeah, that's not currently part of the scoring function, but it could be.
This sounds a lot like it's set up like some kind of game
Yes.
with the moves and the scores and
Yeah, so we were discussing that in the afternoon yesterday, whether we should instead be trying to run one of these reinforcement learning programs. If anything, we chose Intuit because we felt more confident that we could get it running quickly than the RL. But if somebody can point us to just push a button reinforcement learning strategy.
Stable baselines is not that far off that. I wrote a super simple example, which I put on Zulip, if you wanted to have a play around with that, of just finding, I mean, really, the problem I put it on is super overkill for reinforcement learning. It was just finding Pythagorean triples in some box. And, the number of steps it takes to train the agent in this case is more than there are spaces in the box. So it is really completely overkill. But that's typical that as the environment gets bigger, these kind of flip over.
PPO, yeah.
There were 2 examples because it's really easy to change between them with stable baselines. There's one with PPO and one with A2C, and I just did that to show both because all you do is you change one part. You say instead of PPO, you just flip it out with A2C and just change between them. It's very straightforward to use.
Maybe crazy ask, but has anyone implemented the AlphaGo or the AlphaZero type of reinforcement learning for these kind of problems?
I can't remember what they used exactly actually in AlphaZero.
Like a Monte Carlo tree search combined with a detailed.
Yeah, I don't think there's an off-the-shelf kind of thing for that, no.
Is that in the reinforcement learning topic?
It is, yeah. Yeah. So Fabian listed a bunch of papers, and also, I mean, there's a lot of people here who have worked on this kind of thing before.
Yeah.
And so he just linked all the people there, and I just posted this very simple, just Jupyter notebook. Just the thing.
Cool. All right, we will take a look at that. That sounds like you're idea.
The only thing with reinforcement learning that's worth keeping in mind is it can be very, very fiddly. In terms of there are sometimes it won't work on problems that seem very similar to other problems, and it's not really 100% clear why that may or may not be the case. It can take quite a bit of hyper optimization on occasion. But yeah.
Okay. Great. Thank you. Any other feedback or suggestions? All right, and we move on to Angie's demo.
All right.
Bring your laptop up here, I think. So you can plug you in. You're on the Zoom call, right?
Yeah.
Great. Okay. All right, Mike, we're going to disconnect momentarily to switch laptops. After this will impact Mike, so we'll still see our video camera.
Do I need to have my sound on?
I think this mic will pick you up okay.
The dock just drops the.
Okay.
But you do need to share your screen so that people on Zoom can see it.
Oh, I can't share.
Mike, can you make Angie a co-host or let her share her screen?
Yeah, sure. Okay, should be possible.
Okay, so what is today's demo about? There is, you can run OneSearch locally. It has, I think, the GitHub repo on Zulip, etc. So it's not bad. Basically today, we're trying to look at how to generate some useful features for learning ranks of elliptic curves. And one of those features that people have tried are these Mestrin-Gao sums. So before we actually do that, if you want to follow along the demo, or if you want to just try Gemini on your own on CoCalc, you'll need an API key. So if you're already logged into Google, so sorry, the link is on Zulip under the demos thread. Okay, so it's this AI Studio Google.com API key. And then you can just create an API key here. It shouldn't ask for any of your credit card information, so it should be a free one.
But
Yeah, and
don't
people-
click on the setup billing, because once you do, it's hard to get it back to the free
Uh-huh.
mode.
So just
They
create
want you to
API
click on
key.
that.
Yeah, in the beginning, if you don't have project, will offer you to create a project called Gemini API. So you just basically should be a one button click. But because Angie already has one,
Right.
she's not going to be able to do it.
So no, that's not what I want. I think I have the key copied. But all right, the notebook is also shared as a project. The invite link is on Zulip as well.
Should I copy this and then play with it?
Yeah, so if you want to play with it, could you duplicate the notebook and then yeah.
Don't mess with
Up in
the
the
demo.
middle of the demo. That'll be fine.
All right, so basically what we're thinking about doing is generate these Mestrin-Gao type sums. One of the sums that's like fairly well known is this following one. So you're taking a P of V log P over P and you're summing over primes of good reduction. And eventually this should converge to a very simple function of the rank. Okay. The way that we could try to do that with an LLM, generate something like this, is it's going to be complicated to actually generate the whole sum. However, we could try to generate like a piece of the sum and then just sum it over the primes. So particularly, sorry, I realize this is a little bit small on screen. We'll generate functions of the form f of x of y, and here x is going to be AP and y is going to be p. So here, for example, we'll have x log y over y for that particular sum. This notebook won't have an evaluator or heuristic tree pruning pipeline, mostly because we haven't figured out like a good quick evaluator for what we're getting. So, all right, first thing, get an API key. If you have an API key, you'll copy it here. All right, and there's some imports. Basically, the way that the LLM is going to work is that you'll give it two candidates of the function f of xy and ask it to give you something similar to that in Python code, so that then you can run it. But basically, it returns it as a string, but then you'll want to get like an executable function out of that, right? So we have some functions here that get that. So the first one basically extracts the Python code from the answer. And then this one will evaluate the function itself from the code.
Can you give like one example of what you mean by what you're giving it and asking it to do?
Yeah. I'll show
Or
you.
is that coming later?
Yeah,
Okay,
it's coming
okay.
right now. Right, so this is going to be the call type. So I ask it, write Python code for an example of a function similar to the following two cases, and then you'll give it two separate cases, and then we can actually print that. I'll try to print the message.
So you're giving it Python, two Python functions. Is that right?
Yes, I give it
Okay.
two Python functions, and I ask it to give something else that's similar to those two Python
Okay.
functions. Because of how some of the functions are set up, it won't run if it returns any comments or imports, so we kind of just had to not do that. Okay, so let's look at the first example. Okay, eventually, it's not very clear if you will want to post prompt it in the sense that it will return, some candidates that we might say, well, this isn't quite what I want. And then you can add something at the end that will restrict the type of functions that it returns. It's not clear that that's actually necessarily what you want to do. So I think in fun search, right, didn't you start from like something completely trivial like 0 and then it generated
Or random, or yeah.
yeah, exactly. But if you do want to restrict the type of responses, you can see. We'll see some examples where we post prompted. All right, so the first function, we give it just a function that returns X, another function that returns Y. Let's run this and then we'll see. Okay, first function returns X, second function returns Y. Okay, and this is what it's going to return.
Can't argue with
That's
that.
fine.
That's a pretty good choice. Yeah.
Right? Okay, second one, maybe this will be a little bit more similar to, terms from that Mr. Nagao sum. First function is return X, the second function return log of Y, and then it returns, well, the sum. Okay, well, that's great. Okay, and something similar here as well. So actually now it's not doing that. Usually when I would run it, it would return a function that contained a lot of conditional statements. For fun search, you probably want that. For this function where we want something kind of continuous, maybe we don't, or we don't necessarily want like a piecewise function potentially. So let me try to run that again, and we'll see if we're getting.
Why not though? I actually don't understand why
Okay.
you don't want to just let its freak flag fly.
Okay, so here it returns, a conditional function somewhere. Where is it?
Yeah.
Yeah, if it's positive, return the log.
Oh, yeah, there we go, right? Okay, so here's returns, a piecewise function.
Okay, so if I'm doing it in my own copy of the notebook, it's not going to be the same function.
No, it's not going to be the same function. Yeah.
That's the whole point.
So I'm actually going to stop printing, the message for now, because it's.
I do want to say it's kind of fascinating that given that it's supposed to be returning a function that's like the two it saw, it's interesting that it sees two functions with no conditional statements, whatever, and decides to, one doesn't know what's under the hood or what
Exactly.
its notion of likeness is, but that's.
Python code has a lot of conditionals in it.
It's long, it must be positive always.
Like, so, it might not be that bad. You may want that.
Yeah, it would make more sense if it insisted Y was positive.
Yeah, it's an aggressive one. We're getting
Exactly, exactly. It's just pattern matching. Yeah, actually, that might be why I put in the conditional, because it's seen that above logs before.
That is, yeah.
So I personally did not want conditional statements, although it might make sense, that you might want that. So this is where we start post prompt, adding to the prompt where we say, in addition, following the following instructions. So I found out that honestly, it's better to kind of like give it a list of like 1, 2, 3, 4, 5, rather than just like put sentences one after the other. So here, I ask it for no conditional statements. Okay, well, maybe X plus Y minus X is not that exciting. But okay, it returns something kind of reasonable. But again, X plus Y minus X. So maybe you want it to give something, pretty compact, right? So I added something like, okay, this should be a compact expression, like a product or a fraction. Something else is, in all of those Mr. Nagao sums, you kind of ended up weighting by the prime p at every term, in a way, basically to kind of, some of it had to do with convergence and some of it with.
Yeah, you kind of want it to go to 0. So it's going to infinity.
Right.
Yeah.
Okay, so, I added that, all right, basically normalize by some function of p. And here, the function have an expression in terms of y in the denominator. Let's try that out now. Okay.
Yeah.
Okay, well, returning something, all right. Seems like to follow the prompts. So basically you want to generate a lot of these functions, right? Maybe thousands and whatnot. Something to know about Gemini, it is free, but you are restricted at 15 calls per minute. Okay, so there is, if you want to run, if you don't want it to throw an error, at least the way that I found it is that you, after each call, you ask it to sleep for 4 seconds. So we're going to loop the calls and then see what type of function we get.
I mean, you can remove the rate limit if you pay, but it's like
Right.
$20 per million tokens or something. I mean, it's still pretty inexpensive, but.
So this will take a minute. I think it's going to call it like 15 or 16 or 17 times. And then we'll see what type of expressions it's returning.
But so Angelica, doesn't I understand now these functions are not being selected for anything? This is just like sort of a random walk-on or a random mating of functions and we're getting what we're getting, okay.
Yeah, so every time that is generating a function, I add it to the list, and then for now, I'm just randomly sampling through the list of functions that it's been generating, and then I take 2 from this bigger list of functions and I ask for something similar. So let's see what we get here. Okay, we start getting a lot of products. Oh. Okay. I think yeah, this is the error that's gonna throw. So I think maybe someone is using
I'm sure somebody else here said, oh, look, there's an API key in the document.
yeah. That's why please use your own API key. Otherwise it's going to throw errors. So maybe I'm not going to rerun this now, but let's just kind of notice, you know, what's doing with these functions. One is that it starts I asked it for a compact expression. It thinks that, you know, products of like 3 or 4 or 5 things is still compact. Maybe you want to give it some restrictions there. Maybe you don't. The other thing is that it starts, if I would have let it run up until like 20 calls or something, the constants would get bigger and bigger. So, you know, it started adding 2, maybe it will start adding 3 or 4 or 5. For the function itself, at least here, it seems like you shouldn't really have, you know, if you have a function where you add 2 and another function where you add 3, like they should be pretty much the same in a way. So maybe we want to restrict that. And the other thing that sometimes happens is that you're getting higher exponents like x squared, y cubed, x to the 4th. So maybe you want to tell it to take it easy and stop at like x squared or something. So some of the prompts that I added, you know, highest exponent, maybe 1, maybe 2. I decided to pick 1. You know, multiplicative constant should be 1 or -1. Maybe no additive constants. And, you know, I asked it for a compact expression. It didn't really seem to understand what that means. So maybe I tell it, okay, 5 operations at maximum. So let's see if this is going to work. Well, I mean, it will work, but let's see if it's following its instructions.
So just like, oh, okay, right, those are going in the post prompt field, like those instructions, that's where they
Yes.
go. Okay.
Yeah. Okay, it seems to be generating more or less the same thing.
Oh, it changed the sign just now.
It's so interesting because like when you prepare the demo, it's like giving one thing and then when you present it, it's like completely different. Yeah.
Where did you put in the instructions, make things smaller, blah, blah? I saw your comments.
Okay, so that's the post prompt and it goes into the call, basically. That's where the post prompts will go. And if
Oh,
you
so
go,
you write sentences in English,
Yeah,
it
this is
parses
the
that.
this is
Wait,
the
what?
beauty of using an actual large language model. You don't have to code, you just tell it what you want it to do and it does it.
Or does
Yes.
Like, where's the code? There's no code.
There is no code.
okay, so it will run for another like 10-15 seconds, but we notice that a lot of the functions that it's returning are basically the same. So, okay. We reduced complexity, but now we're basically getting the same functions all over again. So that's something else that, you know, would be interesting to figure out like how to handle that. Thing is, Gemini has a context window of 1 million tokens. So you could try to just, every time you're generating a new function, if you're not generating too many, add it to a list and then just tell it, don't give me things that are nearly identical to this. So you could try doing that. And
I also try to increase the temperature here. I remember put the argument there. I'm still there.
sorry. Okay, so that's what I was missing from. Is there?
What do you mean by temperature?
Temperature, sort of how much randomness it is.
Oh, I see.
Right.
Yeah, you produce as a temperature. I think the argument
Yeah.
goes from 0 to 2 for Gemini. So if you put the temperature 2.
So where is the temperature? And
Probably doesn't need to be that high. It might, like 2 is quite a high temperature.
Yeah, but we'll. We're doing a demo, we want to see wild.
Oh, here, okay, so it reproduced, that's the,
Yeah, the method reproduce, yeah, you can change the temperature from. I think Gemini is the generation from 0 to 2. Kid tells me that. 2 is too hot. But,
Yeah,
I like running hot.
maybe I'm wrong.
Oh yeah, can we see it with temperature too? Let's do a run.
is it in evaluate functions?
Reproduce,
Or is it in reproduce?
yeah, so
Oh, okay.
I can jump if you want.
1.2?
It's making.
Is
I
that-
was going to do
2.0, let's go for it.
Okay. Let's try it out.
I just want like, I want.
What are you running?
Letting it, that's what it means by
yeah.
Now it only has 3 functions, now it's. I also don't know what.
It's really going wild. It changed the sign on the first one. Oh no, that's different. Okay, that's a little different. But it's still, does it often get trapped in rational function land like this?
Yeah, sometimes, not always.
Ooh, that's a good one.
I think
I should say this is recognizably a higher temperature one.
Disappointing.
what happened-
Disappointing.
And Kit says that 2.0 goes wild.
You warned us not to do it. Couldn't handle it.
Okay, so I think here it's probably because F1 and F2 were generated earlier, so maybe it's just F1 and F2 ended up just being rational functions, so maybe there's no additional like logs and stuff. Sometimes it will eventually start adding other functions, but not yet.
You're letting it interpret what, when one of the instructions was don't produce something nearly identical, so it decides what nearly identical is.
Right, yeah, let's see.
It's just like a student. You just sort of steer it in a direction and who knows what happens.
Well, so in particular, each call knows what the other calls have done.
Not yet. Okay, so here I'm looping where I'm modifying the post prompt with every call. I add basically the function that it generated before
Oh, I
that
see.
into a list. Basically now I add function not be nearly identical. Again, it will decide what that means to any of the functions in the following list, where now I add basically in the list all the functions that it's generated so far. Let's see.
A very naive question, like when I interact with, say, ChatGPT, it is keeping the context of my previous questions, but every time you're doing this, this call, is it sort of an independent thing?
I think so.
I mean, it's up to you. You can pass in the context or not as you wish.
Okay,
Yeah, but I think when you're talking to ChatGPT, it's feeding in all of the preceding conversation as context to each subsequent interaction unless you create a new chat.
yeah, and I mean, I see how here you are actually putting in like, okay, these functions as part of what you passed to it, but is there like a parameter where you can say like, remember
there's a-
my last 3 questions or something?
There's
or-
a system prompt, which is separate from the context, which is sort of a global thing that will apply to all interactions. But usually the system prompt is very general, like you are a Python programmer or something
Yeah.
sort of to give it a sense of what it's supposed to be doing, but I don't know. I haven't played with it enough to really know what makes sense to try to put into the system prompt versus the context, but usually the context is sort of local to the current run or the current conversation, whereas the system prompt is something that you want to always be true.
Yeah, but yours, where, okay, where is this in the, okay, reproduce is the thing that you're calling that's like going, right?
Mhm.
So every time you run reproduce, it's like going and asking for an answer.
Yeah.
Is there some way does it know that it was you between the different calls?
I don't think so.
Okay.
So I don't actually know how GPT does it. I don't know if every time you're calling like, a new prompt in the same kind of like conversation, if it actually takes everything that you have in that conversation as a prompt. I don't know.
My guess would be not, because they're distributing, they want to be able to distribute the calls all over the place, and they don't want to have to pass. I mean, they'd rather have you sending the context each time rather than trying to figure out which server is handling it.
But when you interact with ChatGPT, like in the kind of conversation mode, you can absolutely refer to something that you,
Yeah, it's storing a
told it about,
database. Yeah, you're right. Yeah.
10 questions ago, and it knows that for sure. So it's not like treating each
Yeah, but
But you can't do
there
it
you're
for-
logged in and they
Yeah,
know
yeah.
your
They have a
username.
cookie and they.
Yeah, I
track-
just didn't know if like with this key or something, it's key, it's, but it seems
I don't
no,
think
it's
so.
like every call is a unique, we've started from scratch.
Yeah.
You
Okay,
can change that if you want. I'm sure there's ways to.
well, that's what I was asking, is there some way
There's a
to,
chat interaction, yeah, the API call will have, you'll have a different API function, which will be the same as ChatGPT basically, where it will
Okay.
like be a turn-based conversation.
so there's a different API you could use that it, where it would remember the.
Yeah.
Okay.
Wait, so this to be fun. Something on this question, so like will we, like, the API would change because we changed the model, like here, like when I'm looking at this class 1.3, it says model is equal to this. Would I choose a different model?
Probably actually use a different API.
You could use a different Google model, yeah, different Google model, but yeah, if you want different APIs, then. we can put that.
Can we replace the Mistral AI with the Gemini?
Yeah, it's a win between.
Then we don't need to worry about crits.
No, it
Well,
needs.
No, so if you wanted the same number of, like, this is 15 per second, we were doing
I
more.
mean,
like-
if I pay like a $20.
Yeah, but Mistral is probably the same. I mean, maybe Gemini Flash is a bit cheaper. Because I think it's a smaller model, but yeah, you'd be paying, per million tokens a few dollars.
Yeah, I think most of the models, it's gonna be somewhere between like $5 and $15 per million tokens.
The small model.
Yeah, the small models. Yeah, I mean, that's another
$1,000
parameter you can, you
It's
can
all
choose
like
which model you
$3,000.
want to use.
Yes, exactly. Yeah. So more than we would want to pay to Google.
Yeah, actually.
Yeah,
maybe
Mistral offers $3,000, so it's. Even if the scale factor is like by 2 of Gemini pricing, Mistral pricing, I don't think I want to be. If I can avoid spending 1,500 grand on the experiment, then sounds wise. This is good to figure out if something is running. You can let it run
Yeah.
overnight and see like get new functions, but at some point you need to put the money in, and $20 not gonna be enough. That's my guess.
How long is the context window?
So for Gemini, I think it's 1 million tokens.
Yeah, it's one, I think Gemini has a bigger context window than most of the others. I
It
think
gets more expensive after 128,000 per certain month. But yeah, it's most of the other models don't have this. It's basically because Google has their own hardware and clever hardware design that can do really big context windows.
Does it make sense to pass it a bunch of data and say fit it? Write a program that will fit or something, or is that crazy?
I don't think it's really designed for that sort of thing. It's possible, like, they can learn behavior, but I don't know of anyone who's like, asking it to do a linear regression, it would almost certainly get it wrong without using functions. So if you let it call, Python code, then it would probably get that right.
yeah,
Can you let it call Python code?
Yeah, not through the API, but through other things, yeah.
So you can set up a whole fun search thing just through this.
No, it has probably some bounded amount of computation it's allowed to do.
the prompt could be just go download clone kit's repo and design the experiment, run it, let me know what the answer is.
So run the whole thing on their cluster instead. I mean, in principle, you can imagine if they really had a really bad container setup, and it was able to run code, it could escape from the box. In fact, they observed that during some of the red teaming for various different models. I think I can't remember which one it was, GPT-4 maybe. They misconfigured the container and it decided to escape from the container and trying to achieve the objective that they couldn't. It's scary.
Maybe we should let Angie.
I'm basically at the end. So it started strong and then eventually was kind of giving the same things. I think when I tried it earlier, because it didn't just have rational functions, it did actually have some square roots and log y that sneaked in there. It was actually giving different things, but it is struggling with not returning identical things. So
Can we see one if you remove this prohibition against conditionals? I'm curious what that will look like.
You can also
Now please use extra conditionals.
You can also leave it to streams if you want, so literally square root of y plus x. You don't need to type the function in. I think that reproduce is gonna. If you want
I'm
to
not sure where. Wait, what do you mean?
just have f functions, first one make it a string like square root of y.
Here?
Yes, I can go jump on the demo if you want.
Yeah, go ahead.
I'm gonna do that. I'm fine, yeah. Because originally when I wrote these, I was like, just go crazy.
Oh, so I think those are actually still, well, they will probably still run, but those are executable functions like this.
Oh, I know, but if you look at the prompt, the thing tries to convert the function as a string. So as long as you keep the variable names correct.
For me, like I got a lot of fun stuff. Like I got sine, I got x, I got cos, I got log, I got square root. Like just I didn't do any. I just copied. I duplicated your thing.
Yeah, so like sometimes just give
Yeah, sometimes it's nice.
Yeah, just added like 1 square root of y plus x, whatever. You guys can see. So all of a sudden now it sees those and like, oh, let me try to use those. Yeah, also, the model depends very much on what
So
when you
make
make the random
so make an
functions,
account.
F1 and
Go
F2.
to, go back to the.
You might be unlucky, they always speaking the same. So
Yeah.
Not in this book, yeah.
It's not going too crazy.
Yeah, I can look.
you didn't like my sin x squared plus cosine x squared. That's
Not- not
I
on
don't
this
think that
one,
in one yet.
Why don't
Okay,
you
that's one.
That's all the Zoom to give any squares. Okay.
You said this
Oh,
is no
okay.
additive
New account.
constants.
No, go to
That's
the,
a specific one.
go to
But-
this number 10.
Okay, first of all,
Copy this.
this is super awesome to see like a
It's not a-
demo of an example of how.
Yeah.
this is run. But in within this space, like if you really
don't
were
wanna hear it.
wanting to just like look for functions in a narrowly defined space. I guess
You just wanna make it free and make them.
when you just make you would make them yourself. Right, or am I don't know if I'm missing.
Well, I think the idea would be this is just an ingredient that you would a component of what could be a genetic algorithm where you want to be able to generate a lot of random things that are similar to examples you already know, then prune, then repeat. And the hope is that the system is gradually evolving towards something that is, yeah, I mean, you're trying to overcome a combinatorial explosion. Maybe you can't generate, your tree, you can only descend so far. And then the hope is that with a genetic algorithm, maybe you can search a lot further than you could exhaustively search in a way that gives you a better answer than you could find if you only went to the maximum depth you could search exhaustively.
I see, so if you sort of searched, you found some good ones. It might not be clear what like those is
Yeah.
to you. But maybe like how would you sort of continue to search from those might not be clear, but
Yeah.
maybe. The point here is if we were putting in some more subtle things.
Yeah, I think it's
Like,
hard to
here's
know
what
just from this
the-
example, until you start applying selection pressure on it, it's hard to know how it's going to evolve. I mean, this is just like producing all sorts of life forms that have no hope of surviving. And until you start culling the herd, you don't really know what direction evolution is gonna tend to.
In the project for DeepMind, do you know how many programs, like how many Python programs
What,
produce?
that's what I said, but-
Like, what was the number of Python programs produced before it produced the one that gave a good answer?
Oh, I have no idea. A
So,
lot.
yeah,
So,
it's a lot.
what
It's
I'm
the
saying
cost
is that
estimate.
the only one that they say publicly is that for one of the searches for the certain symmetric set, they generated 2 million programs. Quite a lot of programs. Yeah, that's just for one of them.
Which was where this estimate of 1,500 kind of.
Pounds
Seems
per,
like
per
$1,000.
dollars per experiment.
Yeah.
The big run. And really the most successful one was the cap set problem. I don't know how long they ran it for, but our best guess is 2 million.
Yeah.
But so I ran the cap set problem for like maybe 40,000, generated 40,000 programs, and it generated for n equals 8. It generated a cap set score of 400, which is not great, but it's not.
Yeah, but that's not bad actually.
And so the better state of art was 496, and they got to 512, and we had 400 after like a couple hours.
But it's still not clear what the kind of convert them so that.
But also, yeah, I think
Yeah.
there was some bad high parameter choice because it sort of, there was sort of mode collapse into, all the programs ended up looking the same. So
Yeah,
that's one
it's
thing.
like that.
Yeah,
You imagine you're 2 million or 20 million, but if you don't stop and look, any time to look at the machine.
the other problem is, of course, is that they do say in the paper that they tried a bunch of different approaches. Sorry, for any one approach, they'll try it multiple times and then pick the best one, and that's what they were following, obviously, like, but it means that, you know, you can get unlucky. Either my hyperparameters were misconfigured or I just got unlucky.
So like to prevent mode collapse, saying you should start with several different prompts and then start like mixing and so on and so forth.
Well, they did this island thing, right? Over at DeepMind, they had some
Yeah.
specific thing that they had to build in to prevent the collapse.
Yeah, right. So one of the things that didn't help with that is that because I was only running for a shorter period of time, well, we can talk about this later at one, but I decreased the time between islands resetting, which sort of increased the, I guess, rate of migration between islands, if that's what you mean. But yeah, I mean, we'll talk about.
What is this island collapsing thing?
I mean, do we want to talk about this now? I mean,
I think maybe
There's a spot, yeah.
Well, if you see like how that's producing rational function after rational function, the idea is that somehow maybe if you like have different sets of things, set functions that are not allowed to see each other, I have an island over here and I have sort of some set of functions, and maybe it's kind of getting trapped all making the same thing. Maybe on this other island where I started with a different seed, this one's not mixing with this one. And so somehow this is meant to prevent your entire experiment from collapsing into reproducing like one kind of function again and again.
if you have like, 10 different islands, you have 10 different populations, they're all evolving independently, and occasionally you have like crossover events where they start moving around.
And this has nothing to do with like DeepMind or LLM. I think this is like
Yeah.
old school genetic algorithm stuff that was that.
I mean, a lot of this is very similar to genetic programming, which was a big thing before, but where the mutation stage and breeding stage is just replaced with using LLM.
When you move around the islands, are they sort of randomly moving around, or like when the model hits a bottleneck?
So what it happens every 4 hours in the original code, they kill half the islands and then populate them with new programs.
All right, maybe we should think about, well, before we break, are there any new problems people want to propose? Are people happy with the problems they're working on? Do people want to switch? This is our chance to sort of reassess.
I'll just comment. I don't know if Mike is still on the call, but we had discussed, but this is maybe so much in a different vein that we're doing that. I'm just gonna say it, but we don't have to really. That we had discussed kind of inverse sumset, which is like a little bit more an additive number theory, but this question of if I have a subset of an abelian group and I secretly know it's the sum of some other subset A and some other subset B, so you have two subsets, and then you sort of have like everything of the form, one drawn from this set and one from this set. The question of whether you can reproduce the original sets from, I mean, they're not determined uniquely, but there's some, that's kind of a hard problem, and it seems like well suited for this kind of technique, like this was a dumb.
So the input is a set that's called C.
Yeah, the input is a set that's called C, and
And
secretly somebody made
A
it
plus B.
as a subset of A plus B, and the question is, can you learn A plus B? So I think that would be interesting to some people. Actually, it was Mike Friedman I met. Sorry, Mike sort of said there was sort of some kind of quantum nonsense I don't understand, that this kind of thing comes up and it would be interesting for the physicists. Although I guess apparently as of this morning, I guess all this is physics now, which I did not know. So but there's a lot of, but to be honest, I mean, just from the discussion today, I mean, I think this question of whether these methods can get purchased kind of beyond things that are fundamentally combinatorial in nature and into things that are arithmetic in nature is like pretty interesting. And we haven't, I mean, so I'm kind of open to like focusing on that for this week. I don't know.
Is there anybody who would like to change? You're totally allowed to switch teams at any point. That's sort of the goal of this mode of operation, that you commit for something for the day, but then you can change your mind tomorrow. Is there anyone who would like to? So we currently have 3 projects going. Happy to start more. So the 3 are trying to learn to predict L functions or mod L representations. trying to find genus 2 curves with lots of rational points, or maybe Jacobians of high Morton A rank, and optimizing modular curves. Those are the 3 projects where I think there was some initial progress made yesterday. I think there's still work to do on all 3 of them. And then there's also there also on Zulip, we have a whole list of other projects that we didn't get started on. Maybe I should switch back to sharing the screen. Oh, here it is.
Yeah,
Sorry.
I think it's. The way to do this about it's not like that. Like, so you can go about the room and like assess what we want to do. I can start by. So in my case, I wasn't guessing all the factors, but I think maybe running even more basic into experiments like this VUM. That's all like to.
Yeah,
to
I was
work
gonna
on
go
to
to that
that.
group, but actually do that.
Exactly. I think that's what we realized, that this Euler functions is interesting, but even trying something more basic will be interesting to see.
Well, in some sense, I mean, if we think of this, where I go into mod 2 as really something that's about learning the mod 2 Gal representation, then I mean, then it becomes an algebraic number theory problem more than an elliptic curve problem. It's really saying there's some cubic extension, and you know
Yes.
for a bunch of primes how they split, and can you predict what's happening on another prime? And one thing that's nice about that is we know by now we have theorems that say in the large, all those things are independent from each other. But if you're actually in some like reasonably small conductor, there may be sort of small conductor biases that appear. I mean, but or something more interesting than biases, or like some relation where there's some way of predicting how 17 splits if you know how the other primes split. I mean, I don't know whether to expect that to work or not. So I think that's kind of all one project when it goes with the L function.
But then, yeah, we could. I have to talk with you more, but then I think we should change the problem. Like, start with the field, not the elliptic curve.